we will be doing midterm 2, problem 1A. So I'm going to work with the givens. So we have 15.92 gigahertz. Okay, giga is 10 to the 9. And then with that, we can find omega. And that's going to get us to 10 to the power of 11. Okay, other givens are E of r equals 81, U of r equals to 1, and sigma is 0.4. Next, the other given is our E of I. So we're going to use our right hand rule. So our fingers are going to be pointing this way, and our thumb is going to be pointing up, because x cross y equals z. So fingers crossing this way, z, thumbs pointing up. We know that the y is going to be pointing into the page. So our E of I equals 10 volts per meter is pointing into the page, as represented with the x. And then what we want to find next is where our h of I is pointing, because in this problem we're told to find the incident h field. And also this would be the x, your finger would be the x, and then this would be the z, and the inside of your palm would be the y direction, as shown with this 3-point coordinate system. So okay, so now if we know that k is pointing down this way, and we know that E cross H equals k, well, we find that H of I is going to be pointing down this way, using our right hand rules. So fingers into the page, K is pointing to the same direction, and if you see that our palm is pointing out this way. So this is going to be our H of 1 of I. And then using the other property that H1 cross H2 equals K, or E1 cross E2 equals K, we can find H of 2. So using the right hand rules again, if H is 1 is going that way, and our thumbs are going this way, we can find that H of 2 of I is going to be pointing out of the page. So out. It's going to be pointing out of the page here. And this angle is going to be 37 degrees. Okay, so using 90 degrees, this is 53 degrees. Geometry. Using simple geometry, we know that this angle is 37, and this angle is 53. And then if this angle makes a 90 degree, then this has to be 37 degrees, because the E and the H are perpendicular at a perfect 90 degrees. Okay, now let's go to the math part. So we know that our H2 of I is going this way, and our H1 of I is going that way. So those are important because we're looking for those. Okay, so given that we have omega, what we can find next is k. So k equals omega over c, which is 10 to the 11 over the speed of light, 8, which is 3 times 10 to the power of 8, which equals to 33 point. Next, we're going to want to be finding the E of I equation. So E of I is represented as E naught cosine omega t minus k and then the r. We have E naught, which is given in the problem, and r is going to be finding this r value going down here. So we're going to use basic geometry, and for r we're going to have negative x cosine of 37 also minus y sine of 37 degrees. So after some calculations, we're going to get 0.8 x hat minus 0.6 y hat. And that's going to apply to our equation here. So we have 10 y hat cosine of 10 to 11 t minus 3.3 multiplied by 0.8 x hat minus 0.6 y hat. And we put that all together, our E is we're going to get 10 y hat cosine 10 to 11 t plus 267 x, there's a negative there, plus 200 y. Don't forget there's a negative there. Okay, that's going to be our E of I. Next, we want to change this into h of 1, and that's not very hard because h of 1i is just going to be the E naught over eta naught. Since we're in air, the direction cosine of omega t minus k and r. And remember, this is in air. And when it's in air, eta naught is equal to 377. And that's going to be a constant that we're going to be using when doing these types of problems. So we already know most of these. We don't know direction though. We know these because it's one of the important properties is that E and H are in phase. So most of these problems we don't have to worry about this part because it's going to be in phase for the whole problem. So it's going to always transfer over. So all we need to do is find the direction now. So when finding direction, we can use sine and cosine components. So h1 of I is going to have 10 over 377 multiplied by sine of 37 degrees in the x direction, and then we're going to have negative z hat in the cosine direction, and then the cosine part with the stuff that are in phase. And I'm going to represent that as 3 dots going that way. So after doing the math by plugging in the calculator, we should have x 0.0159 minus z hat of 0.021 and multiplied by cosine and 10 to 11t plus 267x plus 200y amps per meter. You could change it to milliamps per meter, but I like keeping it in amps. So next is h of 2. We want to know h of 2. So our h of 1 of I is completed. Next is our h of 2. Our h is 2 is just going to be y hat. Since we know that from finding the direction in the diagram, we know it's just going to be in the opposite direction but the same magnitude as the e. So we're going to have y hat, and then the equation from flipping it, 377, and negative here because it's in the opposite direction of where y should be going. So so we're going to have that sine of 10 to the 11 t plus 267x plus 200y amps per meter. So